Coriolis force on a moving particle on surface of the earth. Coriolis force. Coriolis force. Coriolis force on a moving particle. Moving particle. Coriolis force on a moving particle on surface of the earth. On surface of the earth. On surface of the earth. Coriolis force. Coriolis force. Coriolis force. It is defined as the Fixious force which acts on the Fixious force which acts on the Fixious force which acts on a particle when it is in motion relative to a it is in motion relative to a rotating frame of reference. The Fixious force which acts on a particle when it is in motion relative to a rotating frame of reference. Coriolis force acting on a particle moving with velocity vector v in a reference frame rotating with an angular velocity omega is given by vector F Coriolis. Vector F Coriolis equal to minus 2m omega vector cross vector v when m is the mass of the particle. M is the mass of the particle. Mass of the particle. When m is the mass of the particle. Coriolis force due to earth rotation. Coriolis force due to earth rotation. Due to earth rotation. Let P be a point. On the surface of the earth at latitude lambda. And colatitude phi. Colatitude is pi by 2 minus lambda. Consider a rectangular Cartesian coordinate system with its origin rigidly fixed to the earth at point P. The z-axis of the system is taken vertically upward. Radially outward from the center of the earth. The xy plane is the horizontal plane containing the point P. The x-axis point towards the east. And y-axis point towards the north. Y-axis pointing towards the north. The earth rotates from west to east. And the positive direction of x-axis. x-axis is taken toward the east. The angular velocity vector lies in the yz. The angular velocity lies in the yz vector yz plane in a direction parallel to the polar axis about which the earth rotates. The vector omega therefore has no component in the east-west direction along the x-axis. If ij and k the unit vectors along x, y, z axis respectively, then omega vector, which vector? Omega vector equal to omega xi plus omega yj plus omega zk, where omega x equal to 0, comma omega y equal to omega cos lambda and omega z equal to omega sin lambda. Let a particle be projected from P with a velocity v. Let a particle be projected from P with velocity vector v, then vector v equal to vxi plus vyj plus vzk equal to xi plus yj plus zk. Coriolis force acting on a particle moving with a velocity vector v in a reference frame rotating with an angular velocity omega is given by F Coriolis equal to minus 2m omega vector cross vector v. Omega vector cross vector v. As the particle has been projected horizontally, the vertical component of its velocity vz, equal to z differentiand of z into unit vector k equal to 0, and its horizontal components are its horizontal components are of xi plus yj, differentiate of x, so I plus differentiate of yj. To find the value of Coriolis force, evaluate. To find the value of Coriolis force, evaluate vector omega cross vector v, which is given by omega vector cross vector v equal to mod of I j k. We can calculate cross vector, and 0 omega y omega z and differentiate of x, differentiate of y, and 0. Then the value is minus omega z differentiate of y I plus omega z differentiate of x j, unit vector j minus omega y differentiate of x unit vector k. Then the coriolis force is, then the F coriolis force is minus 2m in bracket minus y differentiate of y omega sin lambda I plus differentiate of x omega sin lambda j unit vector j minus x differentiate of x omega cos lambda unit vector k. In bracket close. Then the value is minus 2m omega minus differentiate of y sin lambda I plus differentiate of x sin lambda j minus differentiate of x cos lambda k. This is the equation number 1. And the magnitude of coriolis force is given by mod of vector coriolis F equal to 2m omega differentiate of y square sin square lambda plus differentiate of x square sin square lambda plus differentiate of x square cos square lambda whole to the power 1 upon 2 and equal to 2m omega differentiate of y square sin square lambda plus differentiate of x square whole to the power 1 by 2 equal to 2m omega v y square sin square lambda plus v x square whole to the power 1 upon 2. In terms of pole latitude phi, in terms of pole latitude phi, F coriolis force vector is 2m omega vy square cos square phi plus v x square whole to the power 1 upon 2. The horizontal components of coriolis force is given by horizontal components of coriolis force. F coriolis vector horizontal equal to minus 2m omega in bracket minus differentiate of y sin lambda I plus differentiate of x sin lambda j whole equal to minus 2m omega sin lambda in bracket minus differentiate of y I plus differentiate of x j. The magnitude of horizontal component is given by F coriolis force vector mod of z equal to 2m omega sin lambda differentiate of y square plus differentiate of x square whole to the power 1 upon 2. Then the value is 2m omega sin lambda bx square plus b y square whole to the power 1 upon 2 equal to 2m omega v sin lambda. In terms of pole latitude phi, the magnitude of horizontal component is pole latitude phi. In terms of colatitude phi. Magnitude of horizontal components is 2m. 2m omega cos phi dx square plus dy square whole to the power 1 upon 2 equal to 2m v cos phi. The horizontal components of coriolis force has maximum value at the pole. The horizontal components of coriolis force has maximum at the poles. Lambda equal to 90 degree and 0 at the equator. Lambda equal to 0. The vertical components of coriolis force is given by F coriolis force vertical equal to minus 2m omega minus x differentiate cos lambda k equal to plus 2m omega differentiate of x cos lambda unit vector k. The magnitude of vertical component is given by F coriolis force. Vertically equal to 2m omega differentiate of x cos lambda equal to 2m omega vx cos lambda, and in terms of colatitude and in terms of colatitude equal to 2m omega bx sin phi. The vertical components F coriolis force. The vertical components F coriolis vector vertical equal to plus 2m omega differentiate of x cos lambda unit vector k is it x in the direction of plus z axis, which means vertically upward, which means vertically upward. At the equator, if the body has an initial velocity at the equator, if the body has an initial velocity x, initial velocity x, it will appear to be lifted upwards. Okay, thank you.